Now, I've just been having a conversation with a man called Mike who's been telling me how my home and my office is poisoning me. This concerns me quite a lot, so I'm going to share this information with you and possibly come up with some solutions to make sure that we're not being poisoned by where we live and where we work. Mike from Renson, thank you very much for joining us. Fill me in on the story here, because my eyes were opened when you were telling me about the stuff that's floating around our houses.
Right. What we've done over the last 10 years is to reduce our carbon footprint. We've made our homes better insulated and more airtight to stop leaking of energy. Perfectly good, brilliant. The knock-on effect of that is the ventilation rates probably haven't kept up to where they need to be. And so we're now potentially under-ventilating our properties. The effect of that is we are not removing excess humidity, getting better indoor air quality into the homes to breathe, live and perform better. Every material in your home off-gases, which creates a pollutant. And we need to dilute that pollutant to make it to safer levels, therefore improving indoor air quality.
So we're talking about plastics, which I understand release formaldehyde. I mean, that sounds like not the sort of thing I want to have floating around in my home.
Yeah, it's not only plastics, it's every artificial material that is made gives off a VOC, an off-gas. And it's those we need to dilute to sensible levels and extract. But the bigger issue is actually humidity. Because if we don't get rid of humidity in an environment such as wet rooms, kitchens, you get condensation build-up. From condensation build-up, that leads to mould spores, which leads to mould, the black patches we see on tiles, on work surfaces. They then start giving off microorganisms that then affects your respiratory systems. And hence, since we've been building more and more airtight, asthma rates are increasing. So 28 million people in Europe have an asthma problem, and it's not getting any better.
So it strikes me that we should be doing a little bit more to be aware, but also to monitor as well. You've got a little gizmo here that's been running away over the last few minutes and been measuring, well, CO2 here. Just to talk me through the numbers here and give me a bit of context as to whether I should be worried about these CO2 and other levels.
CO2 is a good metric. It's not really a dangerous pollutant, but it's a metric to understand how healthy a space is. So typically outdoor, your CO2 levels are around 390, 400. In a huge volume space like this, I wouldn't expect that to go really much above 800. In a home, it's probably quite easy to get it up to 1500. And in education terms, school tries to limit natural ventilation to 1500 parts per million and 1200 mechanically. And the reason being, performance is lost as CO2 levels rise.
And by performance, we're talking about oxygen saturation. You know, this is our brain food.
The ability to concentrate and stay awake and stay aware. Yeah. So if you're in a meeting room, an environment with lots of people with windows closed, I guarantee an hour in, your CO2 levels will have risen and you start to feel drowsy and everything else. And it's a natural thing that your performance is lost because your brain isn't performing to the same function.
Okay, I think you've helped me to understand the problem. You've articulated it very well. What is the solution? And I'm sure that you've got one, Mike.
We have lots of solutions, and we need to address this on the basis of two aspects. Indoor air quality, IAQ, and indoor environmental quality, IEQ, and they are two different things. So for now I'll talk about IAQ. We need to make up fresh air into spaces to dilute, not remove, but to dilute and continue diluting the pollutants within the space to bring them down to safe levels. That means bringing air in and extracting air. Now, most systems within the regulations are based on fixed extract. At Renson, we believe in demand control ventilation.
So fill me in, what are the differences between those two then?
A fixed ventilation has the same rate running the whole time, 24/7, unless somebody takes a manual intervention. So it's like saying I'm going to leave my car running all night on the basis that I might need to use it in the morning. Demand control ventilation actually monitors the activity of the property, the building and people activity. So In the morning when we take our shower, we cook breakfast, the ventilation rate responds to the activity and increases. We go to work, the CO2 metric identifies that the house is probably now in empty house mode or there's a lot lesser activity, and the ventilation rates reduce. Again, coming home, we start living our lives. And even at night time, we believe in ventilating of bedrooms to improve our sleeping.
Okay. So you've got product around the room, around the booth here. Just chat us through how it works and whereabouts this stuff fits, because I'm thinking about my traditional 3-bedroom semi in southwest London, thinking, you know what, I could probably do with a little bit more ventilation in there.
Yes.
I don't quite know where this fits in.
Right, okay. In terms of IAQ, the actual amounts of air that need to be brought in are relatively small compared to standard opening windows. So what we end up doing is bringing it in via window ventilators, glazed in or over frame, to allow the make-up air system to provide the necessary support for then the demand control ventilation system to extract the pollutants. The louvres on the back wall that you see there.
I tell you what, let's take a wander over here. So that's what we're looking at here.
So the louvres on the back wall here are more of a greater ventilation rate, would be used typically for the extract systems to mechanically extract the air. Now, what you have here is a range of louvres, whether they be fixed into holes, glazed in, surface mount. We have burglar-proof louvres for higher security. We have insulated louvres where they are part architectural and also part active. So you can create a wall facade as we've got behind us here, but only certain sections need to be active to suit the ventilation system.
I must admit, I do like the wall facade thing. That's pretty neat. Again, it's a particular style, but that might be better off in a workplace rather than in my living room.
It's an external product, but if you're going to clad a garage block, a residential high-end home, then yes, it's a very nice architectural solution. Now, I also mentioned IEQ, and this is to do with thermal comfort and overheating. And we have a problem that because we've now built airtight and heavily insulated, our homes are overheating, especially with larger glass areas, as we've seen on a lot of the door products that we see here. Generally, the ventilation rates for thermal comfort are easily a factor of 10 compared to indoor air quality products. So this is where the louvres come back in, of being able to provide significantly much more amounts of air, but we need to work these smarter. We need to think about nighttime purging. When the temperature outside is cooler, we cool the property down, so it uses that spare energy that is free to cool the place down rather than running air conditioning systems, etc. But we're also allowing controlled ventilation during the day to purge the buildings of not only stale air, but also the thermal and overheating aspects as well.
Terrific stuff. Well, listen, Mike, I've learned a whole lot on the booth over the last 5 minutes or so. Very quickly, final question. Tell me, how has the show here been for you this year?
The show is very good. It's good to see some very good customers coming to attend. The product ranges from the other manufacturers here bring a mixed variety of clients in. So, yes, thank you.
Amazing stuff. Well, listen, Mike, thank you very much indeed for chatting us through what Renson does and some of the challenges that I didn't even know I faced in my home.